Okay, in this video, I'm going to go over the multiple choice questions of the second practice exam. Okay. And what was the first one say? Which of the following is not true of the Bitcoin transaction process? After the transaction is verified by a node, it becomes part of the blockchain. Now, after it's verified by a node, it becomes part of the meme pool, where it can actually be picked up by the miners to use to actually record. All right. So then after the transaction is picked up from the meme pool, okay, so this is the next step. It becomes part of the blockchain. No, not necessarily, because then at that point, the miners have to actually add it to a block, run it through a hash, and actually get a hash value that's below the threshold where they can actually add it. Okay. So A and B both, are not true. A transaction can have multiple inputs and outputs. Yeah, that's true. They can have, only one input, one output, or multiple inputs, multiple outputs, both at the same time. It's a variety. So that's going to be D. All right. A transaction is not added, it's not added to the blockchain until after, all this process goes through. Like, it has to be verified by the node first, then it becomes part of a meme pool. And from the meme pool, it's got to be picked up by the miners and added to a block. All right, and this block they're trying to add, these miners have to actually create a hash from it that's below this threshold value, and then it can be broadcasted and become part of the blockchain. So those are the three main kind of steps for this to happen. All right, 2. Let's say the current difficulty for creating blocks in the Bitcoin network has a threshold value of 0, 0, 0, F, F, F. Dang on. Quite a few F's here. All right. Circle the following hash values for the block that would be acceptable. Okay, so this would be the first one. All right. It has 2 zeros, but it has an A after that. So it means it's going to be higher than this. So 0 is the lowest that you can have. Any 1 through 9 or any type of letter is going to be higher than this. So this wouldn't be acceptable. All right. B. All right, it has an A to start out with, so it's not it. Now C has 3 zeros to start with. So that means it's going to be acceptable. It's going to be below this threshold value. And this is also, I didn't put D. Oh man. So it's going to be D as well too, because it has 6 zeros. All right. So it's C and D. I'll need to make a change to the answer key. I just noticed that. All right. So that type of question can have more than one. All right. So all those where you're looking at, you want, for it to be acceptable, below the threshold value, it's got to have the same number of preceding zeros for it to be acceptable. All right. Okay, number 3 here. Brian is starting up a new business selling gym equipment. He's thinking of accepting cryptocurrency, does not plan on using the Lightning Network. Which of the following could be a problem for him? Okay, a dissatisfied customer putting a hold on the transaction shortly after it was made. Well, no, once the transactions went through, there's no takebacks. That's over with. Okay, that's the thing about Bitcoin. Purchases made for small amounts. Well, that's the thing. You're coming in, but if you're coming into this gym store and you're gonna buy like a sports drink or something, or some kind of protein drink, it's really not worth your while to come in there and make a small purchase, because there may need to be a transaction fee added to it or to be processed. It's not really, just using the Bitcoin network directly is not really good for small purchases. You would need to use the Lightning Network, where you can make these small transactions kind of fast, and you won't have to add that much of a transaction fee to it. What about purchases made for large amounts? Okay, well, that would be okay. Like if you're going in to buy like $1,000 worth of gym equipment, it may, if you use Bitcoin, it's going to take you a while. I want to make sure this goes through, but it's not such a huge deal for making a big purchase, so it's fine for that. All right, so what this is going to be is just B. Okay, just B. It's not, the Bitcoin network is not set up for small amounts. The transaction fees, it takes some time for it to run through. It's just not really well that you would need that. Need to be using the Lightning Network on top of it. If the average time for the creation of a block is 9 minutes, the algorithm will what? Well, if it's being created in 9 minutes, that means there's been a lot of hashing power added to it recently. And so for whatever reason, if electricity costs have went down, like more miners have joined in, or if they've added some new faster processors to do these hash functions, they're getting a lot quicker than they should. So the algorithm's like, well, I want to make this more difficult because I want them to stay at 10 minutes. All right. So the algorithm will raise the difficulty of block creation. And how do they do this? Well, they lower the threshold value of the hash requirement. All right. As they lower this threshold, it becomes harder and more unlikely that they'll create a hash value that will meet this qualification. All right. So that's going to be A. Increasing and lowering. All right, number 5. So stable coins are a blank solution to blank issues that plague Bitcoin and similar cryptocurrencies. So stablecoins are a centralized solution that could be 2 different issues they help with Bitcoin here. That is the volatility, because they're pegged to the US dollar tether and US dollar coin are. All right, so there's no volatility there. And the scalability issues, these transactions happen really fast. Like there's nothing holding it back. Yeah, it's because there's somewhat of a centralization to them. It's not the same thing as Bitcoin. We had like this decentralized ledger, I had to keep track of it. Okay, so these transactions happen really fast. So this could be A or C. All right, 5's D. 6. Jill has just joined the F2 mining pool. She will share earnings with everyone in the mining pool. However, she will need to still run her own full node in order to have access to the transaction mining pool. Well, this is false. All right. Yes, she has to share her earnings, but she doesn't have to bring her own. She doesn't have to run her own full node. What happens is everybody that's part of this mining pool, they have access to the node and the meme pool and all that, just by being part of this. They don't have to run their own node. Okay, so that's false. 7. Suppose a financial asset has a 15% chance to earn $50 and an 85% chance to earn 500. What is the expected income? Well, let's write the formula first. Let's erase this stuff first. Okay. So 7. What's the formula for expected income? Well, we have 2 probabilities here. So the probability 1, what's the probability of this first return happening? And then what's the dollar amount? Okay. What's the amount of income here? Plus, we have this other probability times the income if this is probability. All right. And what are we given? We're given there's a 15% chance that the income, or I here, is $50. Remember, it's our random variable. It can be 2 variables here. It can be, $50 or 500. Right? With a 50% chance, it can be $50. What's 1 minus P? Well, this is 85% chance, and there's an 85% chance it'll be $500. Okay, so 15% of 50 is $7.50. Okay, what's 0.85 times 500? Well, that's 425. All right, you add these together, you get 432.50. That's our expected income here. Okay, so the person has this financial asset that look, well, with this probability, I'll get this. With 85% probability, I'll get $500. So he's figuring, okay, what's the expected income? He's just kind of taking the average. He's just taking the average of these 2 incomes and saying, all right, this is what I expect that it could be, the average. In the process of adding blocks to the blockchain, a miner will use the information from the latest block as input for a hash function. If the hash value is blank the threshold, the miner will adjust blank and try again. Well, what they're trying to do, they're trying to get it below the threshold. So if it's above it, they'll have to try again. And what they adjust They leave everything the same except for the nonce. All right. They'll adjust the nonce, the number that's associated with this, the number they only use once. Then they'll try it again. They'll keep doing this until they get a hash value created from the block that's, that meets the threshold requirement. So that's going to be B. Number 9. Patrick Bateman has just made a large purchase of derivatives in the over-the-counter market using Bitcoin. Before he made the purchase, he got with some friends who own a large Bitcoin mining pool. In exchange for some insider information, he wanted them to carry out an attack on the Bitcoin network by creating their version of the block of this Bitcoin transfer. Well, he's wanting to create an alternate block that doesn't contain this transaction. That way he can get his Bitcoin back, and spend it at a later date. Now, we'll assume this insider information is worth as much as Patrick's Bitcoin. All right. So he'll get to keep the Bitcoin. He'll get to use it back, but this mining pool will get the insider information at some point that they can use to earn some money. What percentage of the Bitcoin's network's hashing power will his friend need for this to be worthwhile? All right. We're given a choice at 2/3 for A. B, it depends on the size of the block reward. C, 50 + 1. The percentage depends on whether they add the latest block or not. Well, it's not D. This is memoryless. It doesn't matter if they got all the previous blocks before or none of them. That's not going to affect it. It has no bearing. This is what you call Poisson distribution. That means there's, it's memoryless. Like what you did before has no bearing on whether you add the next one. All right, C, 50 + 1. And that's what it is. You need a majority. You need a majority of the Bitcoin mining network, and that makes it worthwhile to do these double spinning attacks. All right. And B, why is it not? It depends on the size of the block. Well, that's irrelevant. That doesn't affect it at all because everything will adjust. 2/3, you don't need that much. You just need 50 + 1. So that's going to be B. All right, 10. Brian, Jessica, and Tyler are trying to make a Bitcoin transfer at the same time. They all plan on leaving the same size transaction fee tip. Brian is combining a lot of small and spin transactions to send to one address, but the size of the transactions are small. Okay, so he's got, let's write this down. Brian, multiple inputs. Okay. What about Jessica? Multiple inputs, but small. Let's write that for Brian. What about Jessica? Well, she's got one input and one output, but the amount is large. Okay, so that's her thing. Now, Tyler, one input, but multiple outputs. Okay. All right. So what this wants to know is which transaction is most likely to be added by the miner? Well, they're all leaving the same size tip. All right. And so what we want to know is, what determines, whether a miner will pick something up off based on the tip amount. Well, the only thing the miners care about, let me erase this. Only thing the miners care about with a tip is the amount of Satoshis per megabytes of information. All right, so what takes up space for information? Well, the size of the transactions are relevant. All right. Doesn't matter if it's 10 Satoshis or 10 Bitcoin. All right, it's irrelevant. It's just going to take up the same amount of space. It's just like, a hash with information. What does take up space, though, each input, each output. All right. Each one that you have to add more information each time you're pointing to one of these. So it's going to take up more space. And there's only so much space that can fit in a blockchain. So much information they have. There's a limit on it. All right. So that's what they're going to look at. They're going to look at the amount of inputs and outputs. All right. If you have more of them, or either more inputs or outputs, you're going to need a bigger tip. All right. So in this case, Jessica's is most likely to be picked up because she only has one input and one output, whereas Brian has multiple inputs, Tyler has multiple outputs. So that's going to be actually C. Okay. Next thing you remember, if you have a question with this, remember it's just all about the information. It's the information that's costly, that takes up space. You know, it isn't like it could be, you know, 1 Satoshi and 1,000 Bitcoin. It's still going to be the same amount of information as long as they're all just like on, you know, one input or one output. Okay. All right, so that's it for the first part.